Welcome to Coding Adventures. After so many lessons about animations, game design elements, music, and other interesting effects on the canvas, we are back to the basis of JavaScript, and today we're going to discuss about while loops. So let's get started. Alright, so I'm here on my desktop in the coding editor, and as I mentioned, today we're going to discuss about while loops. So we saw until now loops, and we saw how to do loops using the for structure, and also how to traverse arrays with using for of structures. So what is the benefit then of the while loops? And there is a big benefit of the while loops, and that is basically these are very useful when the number of iterations is unknown. With the for structure that we use until now, we basically knew ahead of time from where we are going, and the step. With the while loops, we can basically loop indefinitely until a certain condition is met. All right? So what other better way to understand this one than to do some examples? So let's start first with printing the numbers from 1 to 10, and we're gonna do this first exercise using for. So let's put here a comment, printing numbers from 1 to 10. And the way we can do it for is basically have a for structure like that, I++, and here inside we can have whatever instruction we want to use for printing. We can use println here. And if we are running, oops, and it's not defined, less than 10, and then this is basically the list of numbers from 1 to 10. So let's see how we can basically convert this simple for structure into while structure, into a while looping structure, and achieve the same effect. All right, so we're gonna leave this on the screen. Perhaps we should put here to separate them a println. Let's separate them with some lines, because we want to print on the same page the same numbers using a while structure. And the way we're gonna do it, first we're gonna define a variable I, and looking above basically is this variable. We use the same variable here, but it's fine because this one is inside for. We're gonna use a variable, we initialize it with a value, and then we use the while structure. And while structure takes this form, it's a while, and then in between parentheses we put a condition. So we want to iterate as long as I is less or equal than 10. So basically it's the same condition as the one we used above with the for, right? And now here we have the while block. The main idea is that this code block will be executed as long as I is less than 10. Similar to here, this was the code block for the for, and this code block was executed for I going from 1 to 10 with step of 1, right? Now, what we can do inside the block of while, we can also do the println, and we can print I like this. And I will not run the program now. We have to do one more thing. If I run the program now, my browser will freeze basically. And the reason is this one will execute forever. I is 1, as we can see here. And this one will execute as long as I is less than 10. So we'll just print I, which is 1, 1, 1, 1, 1, 1 forever, right? And the browser will freeze. We need a way to kind of increment I, and I become greater and greater with each step until it reaches 11, and then the while block will stop. So after we are printing, what we are doing, we are also can use the I++ incrementation here. So basically, after each block, I becomes greater than with 1, so I becomes 2 and 3 and so forth. At one point it will become 11, and basically the block will stop and will continue with the next line. So if we are comparing with for, basically we see the same elements. We see the initialization part here, we see the comparison part here, and we see also the incrementation part. Things are reordered a little bit different though with while versus for. And as a matter of fact, there are some people that prefer to do their loops with while rather than for. But nevertheless, this is another way, and let's run the program to see the effect. All right, so we see basically the two lists of numbers. One is displayed with for, and the other one is displayed with while. Simple, right? Again, it just requires practice, and I'm always recommending to write it down on a notebook and then practice it as much as possible. Let me share this one with you. So this is while one. I'm gonna put the program on the chat. So you can basically, you can start from this one, or you can just recreate it from scratch. So this is while one. The program is on the chat. Let's start with another one and do the sum of numbers from 1 to 10, similar to this one, but this time we'll do it without writing the for version first. Shall we? So let's put a comment here, sum of numbers from 1 to 10. And the algorithm is the same that we used with for before. I'm gonna just mention the algorithm verbally, and then we'll try to encode it in the code using a while structure. All right, so basically we're gonna define a sum variable that is initially 0, empty, and then we're gonna loop through all the numbers from 1 to 10 and add them to this sum variable one by one. So sum will have, after the first iteration, number 1 inside, then the sum will be, the number 2 will add it to the sum, so it will be 1 plus 2, then number 3 will be added, and so on until all numbers are added up. And then at the end, basically that's the sum, and we're gonna display it. All right, so let's have a variable sum that starts at 0, and let's have a variable I that we use to iterate through the numbers from 1 to 10, and its initial 1, right? And then we plan to increment y and loop as long as I is less than 10. So we can use a while structure, and we can say as long as I is less or equal than 10, basically while I less or equal than 10, we can say sum plus equal I. We add I to the sum, right? So sum becomes like an accumulator. It accumulates all these numbers one on top of the others. And we should not forget to increase y. It's a very common mistake to forget incrementing this one, even for advanced programmers. Therefore, in order not to have the browser freeze and crash, basically, it's recommended to save the program as often as possible, eventually before running it. So if we have an error, at least we have the saved state and we can reopen the browser and continue the example. All right, so I saved my program, so I hope it will not crash, but anyway, I saved it. And now, here we can have the println, and we can display the sum. Let's save it again and run it. Boom, 55, which is the correct answer because we saw it so many times. If you want to check the browser crash on your side, it's not a problem. Just don't put this line and test it. You'll have to kill the browser. I'm not doing it because I don't want to mess up the stream, but you definitely can, and then reopen it. Just don't forget to save the program first. All right, so yeah, it's simple as this. Couldn't be simpler. Let's grab the notebook and try to put on paper what we learned until now. Actually, what we can do, we can do a comparison between while and for here really quickly, just to have them side by side. We're gonna put in a table. On the left for, and on the right we'll have while. All right, so this is the for structure, and this is the while. And the way we wrote for, it was like this: for. I'm gonna put it as an example just because it's easier to understand rather than explain it in different words. So we said 1 here, I less or equal than 10. I'm just picking the example from today, I plus plus, and then here it was the code block of for. And we said this basically, when we discussed for, basically we also, in order to rationalize this one, this was basically the from part. It goes from a certain value. This was basically a to value, and this was a step. More precisely, this is the initialization part, this is the condition, and this is a statement that basically we can use it in order to alter the variable after each code block is executed, right? And now the way we do this one with while, instead of having this variable declaration inside the for structure, we just declare it outside, and we can have it like a variable starting from 1. And then we're gonna start the while structure here. And we put here the condition. So out of for, we just have only this condition here. We can have the same condition if we want to achieve the same effect. I less or equal than 10. Here we do whatever we want to do, but we have to not forget to actually increment or alter I variable in some way that this condition will become false at one point. Otherwise, the block will execute it as long as this condition remains true. And if this condition remains true, the block will execute it forever, which is basically an infinite loop, and that causes our browser to crash. All right, so we still see the same elements. We see here the initialization, the condition, and then here the incrementation. And basically at the middle here, we see whatever we want to do. So for instance, this is the actual useful stuff. We use their print line, or remember when we did circles, we can also do circles with this one. This is the useful stuff that we want to do. All right. So write it down also on a notebook, and this will basically, just you can refer to it really quickly when you are doing a program on your own. And yeah, that's all we can say about the while loop. And since we did so many exercises with the for loop, basically we can refer to those exercises and convert it to while. As a matter of fact, any for loop structure that we created until now, let's not include those for off. So any of the for I equal structure can be converted to a while loop structure. All right. As a matter of fact, while loop is even a little bit more generic than the for structure. So any for loop structure can be converted to a while loop structure. So feel free to go through all the exercises and pick up for in there and try to convert it to a while loop structure. Now, I want to mention there is another form of this while loop structure. So let me save this one and basically have it on the chat. This is while loop 2. I'm saving it. I'm putting on the chat now. There is another form of this structure. Basically, if we take a careful look at this one, we see that we have condition checked before the actual code block. And this is actually what's happening. This condition is checked and then the code block is executed. And in the certain cases, if the condition is basically not met from the beginning, the code block will not be executed. There is another form where basically this one goes at the end of the code block. So notice what I did. Actually, let me save it as a different copy because I've shared this one with you on the chat. So this is while 3. So notice what I'm doing in this example. I'm moving the while after the code block, just like this. I only have to do is to put a do in front. So it means like this: do this code block as long as this condition is met. Now, if we run this program, we still see 55, right? Perhaps we should go to print just the numbers because it's much easier to see. Yeah, so basically this is just 55. It's working as expected. Let's just print the numbers because it's, like I said, it's easier to see. Printing numbers from 1 to 10 using do while. All right, and now we're gonna actually print inside the number, like in the first exercise, right? Not in the second one. So let's run it. We should see the numbers from 1 to 10, exactly like expected. So what's the difference then, you may ask? Why we have two forms of while loop? And there is this difference. In the first one, the condition was checked at the beginning and then the block was executed. In the second form, this one, the block is first time executed and then the condition is met, is checked. So there is a subtle difference here. In the second form, the block is executed at least once, even if the condition is totally false here, right? So this block will always be executed at least once, and then the condition is checked, so maybe it will be executed more if the condition is still true, like in this particular case, but maybe not. So let's pick a number 11 here, right? Just to see this aspect. Now, I is 11. We start with I11, and now the block is executed. We should print 11, I becomes 12, and then we check the condition. So let's see the effect. We should see 11, right? Which is the number printed before it's incremented. So the block is executed at least once. It doesn't get executed more because, of course, the number 12 will be will be greater than 10, so the block doesn't execute. But in the first case, when while was in the front, like here, and let's remove the do, if we run now the program, we shouldn't see nothing because it's already greater than 10, so we don't execute the block. All right, so remember this form. If you need to execute the block at least once and then use the inverse form, use the do while structure, right? So we can put a comment here. We can put a comment above here. Useful when we need to execute the block at least once. Yeah. All right. So this is perhaps not a very practical example, but in certain cases you encounter this need and you have to remember this form as well. I'm gonna put this one on the chat as well. While 3, and the program is there on the chat. All right. So see, it's not complicated. Perhaps we should pick more examples and let's do a little bit of a practical example this time. Did you hear about Fibonacci until now? Fibonacci series? Yes? No? Let's see what Fibonacci is. We're gonna make use of Wikipedia and search Fibonacci sequence. Wikipedia, this guy. All right, Fibonacci number or Fibonacci. Let's see which one. Let's see if this one is the right one. All right, this is a pretty good one, I guess. So let's look here. So Fibonacci numbers, basically, well, Fn, they come from a sequence, and this is actually the sequence of numbers, of Fibonacci numbers. And we're gonna build now a program using the while loops to print these Fibonacci numbers. Let's see, yeah, in here, it's a better explanation in here about these Fibonacci numbers. We can always see that first number is 0 and second number is 1, all right? And then the next numbers are the previous numbers added together. And this is a very, very good definition that basically also shows defining Fibonacci number using this recurrence relation. In a future lesson, when we're gonna learn about recursion, we're gonna calculate Fibonacci using recursion. But for now, we're gonna just do it in the plain, typical way without this concept recursion, but we're gonna make use of the while loop structures. So the way we're gonna do it, we'll have two numbers, basically a 0 and a 1 here. And then let's say we are interested in printing 10 Fibonacci numbers or 100 Fibonacci numbers. We'll calculate the rest of the numbers adding the previous two. And then we're gonna shift. So the first two will be 0 and 1, and the next two will become basically 1 and 1, and then we calculate 2, and then we shift one more position. We'll always have, in a sense, two numbers that are the previous two numbers. We're gonna keep them in some variables, and then we'll calculate with those the next one. So even when we go in the middle here, at one point our two variables will have these numbers, so we can calculate the next number using this one by adding them together. All right, makes sense? I hope so. We can keep this page open, just maybe we need to refer back to it, but let's get started. Let's create a function, print Fibonacci, and we'll pass an argument here. Maybe we're interested in printing 10 numbers, 100 numbers, so on. So let's invoke the function here and print initially 10 numbers, right? So we're gonna choose two variables. Let's say first number is 0 and second number is 1. So, and we initialize these two variables again with value 0 and 1 because we know already that first number is 0, second number is 1. But these variables will not remain stuck on 0 and 1. We'll create this shifting window on them. So basically we'll assign new values to them. But we'll start them like that, right? Let's print them here really quickly. Just to see them. We're gonna print them in here. And we're gonna print ln. And we're gonna print also the second number. Like that. Now, if we are running, obviously we should see just 0 and 1. So our series gets started. But of course, we want to display more numbers, not just 0 and 1. So let's see how we implement that one. We need to display, well, we said we need to display 10 numbers. Already displayed 2, which are these first two, right? Are already known. So we need to display 8 more. Or n minus 2 more. So let's make a loop structure and display n minus 2 more, right? So let's have a variable I, which can be 1, and then we'll loop while I is less than equal to n minus 2, because we're passing n here and we need to display n minus 2 more numbers. Again, n minus 2 because the 2 one will display already, so in total will be n numbers, right? So what we are doing here inside, it's interesting, right? We need to display the next number here, or to calculate it. We need to basically have a variable, let's say Fibonacci of I, fi. The next number is basically the sum of the previous one. Is the first number plus second numbers, right? At any point in the Fibonacci series, the next number is the sum of the previous one. So like these ones, right? And we calculate it and we can print it like this, right? At one point we'll have to increase I. Let's not forget about that one, and let's put it here because otherwise again we'll get that infinite loop that I was mentioning. Let's name this one Fibonacci, and let's put 1 because I plan to create 2 examples. I'll save it. The program is not complete. We need to create that shifting window, otherwise, see, first number and second number will always remain stuck to this constant variable 0 and 1. But let's run it just to see it. All right, so at least we have 10 numbers displayed here, 2, 4, 6, 8, 10. The while loop structure is working perfectly at picking 8 numbers. But we need the algorithm, we need to make the numbers basically shift on the structure. So what's happening is, let's look at an example here. This is the initial condition, right? And then we need to move to the second position, which is this one. So the first number is becoming the second number. So initially, see, the second number is 1 here initially, right? When we advance the step, the first number is becoming the second number, and the second number is becoming the number that we just calculated. So after we print, we do this one. First number is becoming the second number, and then the second number is the number that we just calculated before. So we are shifting a little bit the window here. So let's run the program again and see the effect. All right. It looks like Fibonacci to me. Let's see here, print up to Fibonacci of 20. That should be this number. And we can also display some nice message. So let's display 20 Fibonacci numbers. And also when we display them, yeah, we can just display the numbers for now. Let's run it. All right. So let's see why is not that number. So we have 0. How many we have? Yeah, because in this sequence was Fibonacci of 0 being this one. So here there are 21 numbers. Yeah, so Fibonacci of 19 is 4181. 4y, so it's correct. So if we are printing 21 Fibonacci numbers, basically we get those numbers. And what we can do, we can print a small f of I in front. So this one is basically, first of all, we can encode this one. This is f0. This is our first number. This is our second number. These are starting conditions, so they are constant. But then here we'll have f of I basically equal something like that. And let's have I, actually we concatenate I, right, into whole expression here. Let's run it this time and we should see them nicely displayed, right? So f of 19, what? Oh, we have f of 1 again here for whatever reason. Yeah. So it's yeah, this is f of y. We can either start here this cycle at if I represent the Fibonacci, or this is represented for how we coded this, represented the number of iteration, right? So if we start of 2 here, we can do the logic a little bit different in the expression, or we can just put a +1 here just to match the index. Oh, and now it happened what we what we don't want is basically because we concatenate a string with a number, this becomes a string. So to make sure that this is a number and I is added with 1, we're gonna put them in parentheses here. All right, so we can see this Fibonacci series, and now the numbers are matching these these ones. So we don't see ours. Yep. So they are matching perfectly these numbers that are on Wikipedia here, and our program is working with while loop structures. And Fibonacci, you should look up Fibonacci. It's a very interesting Fibonacci has a lot of applications, not only in mathematics but applied fields. It's also a pretty practical example to be used in coding. As I mentioned, also when we're going to do recursion, we're going to talk again about Fibonacci. But for now, this is Fibonacci using the while loop. So let me print this one and let me share it with you on the chat. So this is Fibonacci 1. And I said that I plan to do 2 versions of Fibonacci numbers. And I'm going to start from scratch. I'm not going to reuse that code. I'm planning now to create, also to practice a little bit arrays, to create an array, to have a function that basically returns an array with Fibonacci numbers, and then we print them. So rather than the function to do the printing, we'll have a function get Fibonacci numbers. This one will return an array, and then we're going to print them. All right? So let's have that one. Get Fibonacci. And again, we pass an argument. Maybe we're interested in getting 20 Fibonacci number, 21, and so on and so forth. Okay? So what we can do inside, we can have an array of numbers, and inside this array, we're going to put the numbers, right? And then, of course, we can use a while loop structure. We can, you know what, we can use a for loop structure initially here, and then we can change it to a while loop structure as well, right? So, what we can do, we don't need those variables anymore, because what we can do, we can place in this array already some elements, right? The array doesn't have to start empty, it can start at 0 and 1. We already know that the first 2 Fibonacci numbers are 0 and 1. So now we can have a while loop on the array, and basically, yeah, let's have with a while loop directly. So while, and we're gonna do a little bit different. While ar.length is less than n, we are not having that variable that we used before, an I variable and incremented inside. We're actually looking inside the condition at the length of the array, because we'll always push numbers to the array will grow. So we can check, as long as the array length is less than n, basically how many numbers we plan to put inside the array, we can calculate a particular number, for instance Fibonacci of I, as being the previous 2 numbers in an array. So we have to keep a counter on those on that number that we plan to do, right? So perhaps this we should keep a counter, an I counter somewhere here, but this counter will be used not for the while loop, but the counter to have this sliding windows, and sliding window can be 0 perhaps. So initially we refer to this element, and then yeah, let's say 0, and then if it's not working, we're gonna tune the algorithm a little bit, but we plan to start at 0. So phi, it's array of I, ar of I plus ar of I plus 1. at least in the first iteration, should be array of 0, which is this guy, plus array of 1, which is this guy, and we get the next element, which is should be correct. And then we are pushing into the array fi, Fibonacci number of I, right? In the end, we should not forget to increment I, because we need to advance the sliding window. I again is not used in the condition, but is used for that sliding window. So the code looks kind of like that, and then at the end we should return AR. And let's invoke the function here. Let's have an AR here saying get Fibonacci, and let's return 21 numbers. And then we can loop on the array on the for of function for let n of AR. For each number from AR, we're gonna print, or we can have an I here. Doesn't matter. We're gonna print the n. We're gonna print the number. So let's save it. Again, when you are working with these while loop structures, if you messed up the conditions, you may get in an infinite loop. We'll save it just to be safe and run it. And we are in good shape because we got the same numbers here. All right, so yeah, since we are about the while structures here, let's look a little bit here how to traverse an array, basically, also with a while structure. So here we are traversing the array with a for of structure. We saw before how to traverse it with a for I structure. Well, basically, let's have that example. I equals 0, I less than ar.length, I plus plus. So we saw also this form before. Less than n. Oh, we don't have an n. We print the I here. So, oh, no, not I. We don't print I. We print AR of I. Since this time we have I is an index and we have to print the element of that index, we would get the same elements. Now we can also print I here if we want to display, have this one f of I plus, like we displayed them nicely last time. We can also have this expression, and we see the first 20 Fibonacci numbers, or 21 starting from 0. Yeah, we can have also this function. We can make it if n, I'm seeing here, if n is less than 2, the function won't work perfectly. We have can have some conditions, but you know, these are optimizations. We can take care of these ones. But we said let's do this one using an I structure to traverse an array using a while structure, not a for structure. So that's another way. Let's keep this one because maybe we can refer to it when we run the while structure. For this one, we're gonna choose a variable that starts at 0, and we'll say while I is less than ar.length, right? And then here inside, we're gonna use the same expression, same printing, but we take care of incrementing I here because we need to stop, right? We need this, make sure that I is actually is getting increased and will stop. So if we run this one, we should see the same result again. All right, so I think I shared this one with you, Fibonacci 2. No, I didn't share it. Let me put Fibonacci 2, and let's share this example with you as well. The main part was here with the while, but of course we have another example here when we are traversing the array and printing. We can eventually encapsulate this in a function, but these are details, and I think you got the point. Yeah, let's also that condition here, because if we are asking get Fibonacci with less than 2, like maybe if we ask for 2 numbers, we should get them correct. But if we ask Fibonacci of 1, Fibonacci of 1 is returning basically 2 numbers. So what we can do, we can have here if n, if we're asking, so n represents here how many numbers, right? Not the nth Fibonacci number, it represents how many. So if we're asking with 1, it's basically we are returning 0. If we're asking 2, let's write again. If we are, oops, return 0 as an array. so if we're asking to get a number, we are getting 0. If we're asking for 2 numbers, we get the 0 and 1. And then if we're asking for 3 numbers, we're getting there, right? And if it's less than 1, we should, yeah, let's put this condition as well, because otherwise if we put here, let's say -3, we implement this protection, right? This is not correct. Fibonacci doesn't have sense for this one, so we can say if n less than 1, we can return empty array, right? So this takes care of some edge cases, like in case we're invoking the function maybe with abnormal data. So let's put back 21. So again, we'll put a comment here, return n numbers in Fibonacci series, return n numbers as an array, n numbers in Fibonacci series, put here as an array. All right. So I'm gonna save it, run it, works perfectly, and now share it with you on the chat. This is named Fibonacci 2. And have fun with the code there. All right. More examples? Why not? Still early. Let's get an array, since we're in this area. Let's get an array with the first n prime numbers. All right. For this one, remember we created before a function to return to check if a number is prime or not. I'm not going to copy the function, I'm going to recreate it really quickly, but if you don't remember how we did that, and the algorithm, refer to the previous lesson. All right, so let me start with a function first, is prime, that check if a number is prime. And what we can do is basically loop through all the numbers, I equals 0, actually you don't have to loop through I equals 0 to 2, I less or equal than square root of n, I plus plus. We loop through all these numbers. If n is basically divisible with that number, meaning the remainder is 0, we are returning false. Let's put inside the code block here, we are returning false because it's not prime. Otherwise, if we finish the numbers and none is divisible, it means that it's prime, we can return true. Let's check the function, and we can also check for edge cases here. If n is less than 2, we can return false, right? So let's println, just check the function here, is prime of, actually let's do a 4. Let I equal 0, or let's start at -10, I less than 100, I plus plus, print, then actually say if is prime of I, if that number is prime, we want to print it. Yeah, we want to print it just to make sure that we are getting prime numbers. Of I, we'll print it. And of course, we don't see the negative numbers and less than 2, so the prime numbers are these guys, which basically they look like the correct numbers. All right, so we have a correct function to return prime numbers. We are on the chapter about I. We can also turn this one in a while loop. So what we can do, we can have it as this. Let I is 2. We can have as long as while, and this condition from here. We'll have the same block. We check there, and then we should not forget to increase it. We'll run it again, and we get also the prime number. So this function now is prime is created using a while loop structure, right? So let's put here returns true if number n is prime. All right, so we have a function that can check for prime numbers. Let's name this one primes, like this. And we said that basically we want to, what did we say? To return an array of prime, first n prime numbers, right? So let's save it. Okay, so we are not interested in this code here. We are interested in creating another function, get primes, to get a first n prime numbers, and we put here a number n. This time n means how many we want to return, right? So this one returns an array with first n prime numbers. So we can take the same approach as we did in the previous exercise. We can have an empty array here. This time it's empty. We don't initialize it with numbers such as 2, 3, or so on. And we can make a while structure, and we can loop as long as ar.length is less than n, because we need to return n numbers in this array. So this array at one point will have n elements. So basically this condition it's false, and the while loop should stop. So we need to check numbers, right? So we'll start with numbers from let's pick a number here, I, that starts at 2, and then we'll verify if is prime, this number, basically not n but I. If this number is prime, what we are doing, we are adding it to the array, ar.push I. Right. And then, even if we're adding to the array, we're not adding to the array, we move on and check the next number, right? So we just increment here the next number. Oh, I didn't close here the parentheses. And then hopefully the array will be filled with n numbers. If it's not filled, we get in a while in an infinite loop here. But if it gets filled and the array will reach this, the length will become greater than n, which we pass here, basically the while loop will stop. And when it's stopping, we have in that array all the numbers we are interested in, so we're returning the array. So let's have here the array and get primes. We are interested in 10 primes for now, and let's just print it like that, the array. Just print it with one instruction, save it, run it, and we have the numbers. Let's while loop on the array again, just to use a although it's easier just to use the for off here when we traverse arrays, it's not doesn't make sense to use a while loop. We can just say for let I of ar, and we just print ln I, much faster. We'll use that anyway. We'll convert this one to a while loop. Let's have 100 numbers here. Yep, these are 100 prime numbers. Too many. 10 prime numbers are enough. Maybe 20. Let's have more. We like the prime numbers, right? So all these are prime numbers. All right. So yeah, let's convert this one to a while loop. So the while we're gonna do, we'll have a variable here. The while we're gonna traverse. Let's have it in a function. Function print array. Right? And we'll pass what array we want to print. And we're gonna say here print array, and we print array, this array. And we're gonna traverse the array using a while loop function. So we're gonna have an I variable that points to the index 0 in the array, and then as long as I is less than ar.length, we basically print ar of I, that particular element, then we increment I. And now if we run it, we should just get the same result here. Let's print also the index in front of them, just for fun, like the first number, or this one will be 0 anyway. Let's print the index +1 just to be the first prime number is this guy, the second prime number is this guy, and so on. So the first prime number is 2, the second one is so forth. So we have 20. The 20th prime number is 71. All right, so looks correct. Let me check this one with you on the chat as well. Again, practice this one. Primes. All right. Now, one more. Let me mention about another advantage of the while loop. When we were just looping here to the numbers, I mentioned several times we should be very careful to check to increment the condition, otherwise we go in an infinite loop, right? So that was kind of bad, and we wanted to avoid that situation. But there are situations when you actually want to create an infinite loop. Sounds scary, but those situations are useful. So while loop allows you to create an infinite loop. However, you'll not run it to infinite, but at one point you're gonna check a condition inside, and if the condition is met, you can break out of this infinite loop, right? So to do that one, let me come back here, create a new program. And the way we create an infinite loop is this one. You're gonna just use like that. As condition, you just write true. While true is true, basically. Or you can write while 1 is 1. Something that is always true, but of course, it doesn't make sense to write while 1 is 1, because this one is evaluated to true. You can just write while true. So if I'll just press play now, the browser will crash for sure. We need at one point here inside to do some sort of a if, and if this condition happens, what we can use a break, similar to we break from force. So this break will break the infinite loop, right? So this is also useful. So the program initially goes in this one, assuming it's an infinite loop, and looping there forever. We don't know how many times we're gonna loop. Again, the advantage of while loop over for is that we can use it when we don't know how many iterations we need ahead of time. But at one point, this condition will become true, and this line of code will be executed, and we are breaking out of this one. So perhaps we should take an example, right? A more practical example to understand this concept here. And I'm thinking to implement what is called the bubble sort algorithm. We'll sort the bubbles. Bubble sort algorithm is a basic algorithm in computer science, in programming, that you use to sort numbers or other things with them, right? We're gonna use to sort numbers. Now, it's not a very fast algorithm, and JavaScript besides this has already built-in algorithms, but nevertheless it's very interesting to learn how to implement a sorting algorithm, and since this is the simplest one, we're gonna implement it here, right? So we're gonna just write here bubble sort algorithm, and we'll basically use it to sort some numbers. So let's pick an array of numbers, perhaps here, just some numbers of arbitrary values, because we want to sort them, and we pick positive, negative, something like that, right? And we want now to have a function bubble sort that will take as an argument this array. And well, what we can do with this one, it's either return another array or sort it in place. And we can choose to sort it in place, right? So basically, if we're gonna sort, what it means sorting in place, if we're gonna call bubble sort of AR and print here AR, so if we print before and after, first instruction should display this guy, after that it's sorted, so the elements inside get rearranged in an ascending order, and then if we are printing again, we should basically see it in a sorted fashion. So let me save this one. So we're doing sorting in place, basically. We're not returning another array. Let's run it. Right now, obviously, bubble sort is empty, is not doing anything, so the two the two print instruction print basically the same, right? So we want the second one basically to display -1, then 1, 3, and 23, and so on. All right, so the way we're gonna do it, we said we're gonna implement using bubble sort algorithm, and bubble sort is basically looping on this array, and it's looking at two elements. Basically, it's like we have again like one of those sliding windows, right? It's looking at the first two elements here and compares them, and if the first one is less than the second one, we're in good shape. All right, and we move on. Then we advance the window. We advance it by 1, like we're sliding to the right, this window. Then looks at the next two numbers, like in this case 1001, right? And basically these ones are not in order. So what will happen, we're gonna swap them in place. So basically one will become here and 1000 here, and we're gonna move again the window. Now at the third iteration here, we're gonna look at number 1000. Remember, 1000 comes on this position from the previous iteration. We're gonna look at 1000 and -1, and how is 1000 versus -1? Obviously 1000 is greater, so whoop, we move 1000 here and -1 become here. So instead of -1 we'll have 1000, we advance the window, now we have 1001 and 8 and so on. So what you notice is that 1000 is bubbling to the top. That's why it's called bubble sort. So bigger numbers bubbles to the top. And let's basically do this one really quickly. We can do it with a 4 initially. Yeah, you know what? We can do it with a 4 and then also combine a while with 4 just to, you know, so we're gonna sort, we're gonna check these numbers. We're gonna do a 4 on this array with an I equals 0, I less than ar.length, I plus plus. So let's take in a variable the first number is ar of I, and the second number that we want to look at it, b, it's ar of I plus 1, right? Just like that. Let me put some space here, make it, yeah. So these are the two numbers, right? So initially when I is 0 and the second number is at the index 1, right? But the I advances it, and then basically these numbers advance as well. Now here we should not go ar of length because we'll take the last number, and here when we are adding it, is basically going outside of the range. So what we can do is basically, yeah, we can, anyway, it's working fine. We can go one less, but anyway, we're gonna check here if A is bigger, is greater than B. So this is the condition when they are not in order. Then we're gonna swap. So in AR of I, in the first position we put the second number, we put B, and then in AR of I plus 1 we're gonna put A. Right? We just swap them around. That's it. Let's run it once. I'm saving it, run it. All right, something is different. Still the array is not fully sorted, but we notice that 1000 number from here, it indeed bubbled up to the top here, right? But the array is still not sorted because we have 23, 1 is obviously less than this one. So what if we run it again, right? Like we did this time. our new array is the second array, this one. What if we pass it again to the sorting, to all this bubbling thing? Well, for the moment, let me just repeat. Actually, I can repeat the structure like that. I'm copying it and paste it just two times, right? And we see we are a little bit better shape. 23 also bubble to the top, right? So obviously, okay, let me remove this one because we don't plan to copy it and paste it again. Obviously, we need to repeat this for structure multiple times. But how many times should we repeat it? It's a good question. We'll repeat it as long as we don't find any element to sort, right? So imagine the array becomes at one point fully sorted. If it's fully sorted, this block will never get executed because we don't find a bigger element in front of another one. So, and if it's fully sorted, it doesn't make sense to loop again to the array and try to sort it and sort it and sort it. We are looping on an array that is fully sorted, so it doesn't make sense to loop it. So at that moment we stop. So now we're gonna make use of that infinite loop. All right. So really careful. We're gonna create an infinite loop here. We'll say while true, and place the entire code inside this one. We'll just loop forever. We should not run the program now. Again, this one will loop forever, but we need to break out in the moment we don't find anything to sort. So let's have a variable, perhaps. At one point we can have a variable here. Let's say swap, which is basically false, right? Yeah. And each time we go inside, each time we swap this one, let's say swap becomes true, right? So swap becomes true. No, it's not good here. Let's have it inside, initialize it. So before each iteration, yeah, we put it inside the while loop. Before each iteration, we assume that none has been swapped, so we run our for. Now, if we swapped some elements, like here, swap becomes true. And now what we can check, what we can check here is basically before we actually, after each for completes, we need to wonder ourselves if we need to while loop it again, right? So we can verify the swap variable. If in the previous iteration none of the elements were swapped, it means that the array is already sorted, so we can break out of the while. We don't have to go back again. Otherwise, if we are not breaking out, we're gonna go back and back and back in the infinite loop, and this will be not good. So let's check here. If not swapped, right? If we didn't swap any element, means the array is already sorted, so we break. All right, looks all right to me. Hopefully, yeah, let's look at the whole function here. We made use of for, of a while. Of course, the second for we can transform it in a while. We always said about that one, but this one is much nicer written with a while rather than a for. There's a way to write an infinite for, but if you encounter that situation, better use a while. But if you create an infinite while, always make sure you have a break somewhere. Otherwise, it's pure infinite. Or it's, yeah, the computer will crash. You cannot reach infinite, I guess. So let's run it, and hopefully we should have a sorted array. Indeed, it's sorted. Our algorithm worked. All right, so our algorithm worked perfectly. This is bubble sort algorithm. We use it basically, again, we bubble numbers up. I think we can optimize it a little bit here. So let's look at this number. See, after a certain iteration, for instance, a number the first number bubbles up to the top. The second one we iterate to the array, we don't have to iterate to all the numbers, because we know already that the biggest number is on top. We can iterate with one less. In the next iteration, we can iterate with one less, and so on and so forth. So it will be a little bit more optimum to say like that if we iterate with one less, because we don't have to do that kind of extra iteration or extra comparisons. Those are anyway swapped. If we want, we can do this optimization. The way we're gonna do it, we can have a variable here. We take the length of the array. Yeah, we started this guy. We take it in a variable, and basically for each iteration, we're gonna decrement that variable. Let's decrement it first here, and then while I is less than len. And notice, we start at length, we decremented 1, so it's length minus 1 initially here. So it's exactly like we had it before. But next time, notice what's happening next time. After the first for, this variable will be decremented with 1, because we know after each for, the top number bubble to the top, so we don't have to traverse it to the end. So this for, all the other fors will be shorter and shorter and shorter and shorter and shorter. Hopefully it's working. Yep, we still have the sorted array. We are in good shape. So yeah, this is a bubble sort implemented with while loop, an infinite while loop, a break condition here with a for inside that we can also traverse to convert to for if we wish, and also with a small optimization, this one to not traverse all the time and bubble it to the top. All right, so let me share this one with you. I hope that you found it interesting. There are plenty of exercises around these sorting algorithms, and bubble sort is the simplest of them all. So if you want to learn about sorting, start with this one. Bubble sort. I'm gonna print it here. I put it on the chat, and basically, yeah, this is your first sorting algorithm. And actually, see, the coding concepts are not that difficult with this exercise here. It's pretty simple, only simple statements. But the most important aspect here is the algorithm, right? The way we iterate, the way, and these algorithms are basically agnostic to the language you are learning. You can do this in Python, in JavaScript. The language elements will be very simple, but you need to know the algorithm in order to implement them, or implement this one. So this is bubble sort. Anyway, it's a pretty useful algorithm. Let's create one more example with the while loops now, and perhaps we should stop the lesson. Let's do something graphical on the canvas. And I'm thinking of something also another element. It's not maybe that impressive, but it's a useful knowledge nevertheless. Let me grab my notebook here really quick here. Again, recapping a while loop, comparison while with for. It's something that we did there. So also if we are talking about, let's put also this one on the notebook, also about the infinite while loops. So basically the syntax will have it while. Here we put true. While true, like a constant, we open and close, and somewhere for sure inside we'll need to have some sort of verifications, and if this one is happening, we'll have break. Right? It's very important to have a break because of the true here. Okay, this is an infinite loop with a break condition to break from it. All right, so let's do something graphical, and actually it's a pretty simple exercise, but we're gonna make use of polar coordinates. So polar coordinates, you know, with angles and things like that. So that's why I want to draw a little bit. So what I want to achieve, imagine this is the center of the screen, this dot here. I want to draw basically some small circles like that, and have them drawn like on a circle. So obviously to draw the small circle, a single one, we're gonna use the circle function, that's the one that we used until now. But right now we need to see how we basically position them around on a circle. Obviously we're gonna have an angle variable, that this angle will just loop it from angle 0. We'll go to up to 360. So we can loop through all the elements. Eventually we can have a step of 5 maybe, because these circles we can space out. So we're gonna loop that while we're gonna use the while structure. The question is, what will be the x and y coordinates for one of an arbitrary circle here? So for sure we're gonna know the angle A. So we need to detect, the question is, knowing angle A is known, right? It will have a certain value, initially 0, then we'll have perhaps 45, and so on. It will go, you know, it will go from 0 to 360, right? So we know the angle, so we're gonna use a while loop through all these angles. Question is, knowing the angle, how are we gonna figure out the x and y coordinates? We also know the radius here, so we'll also need to know the radius. Let's say it's a fixed constant, 100. Right? Because we can make this whole circle bigger or smaller. So we know this radius, or this one, let's say r. We need the r, we need the angle. How can we figure out the x and y coordinates of these ones, right? So that's the question. And for that one, we'll basically make use of trigonometric functions. Let me draw again the canvas here really quickly to show you how to convert from, basically we need to convert from knowing angle and radius, and we need to convert into x and y, right? So this is a center of that virtual circle. Let's yeah, it's a virtual circle, the one that we are, on which we are placing the smaller circles. So we need to find out basically, let's say for a particular angle, this x and y, right? This x and y. What are these coordinates? We need, let's say this is the x circle and y circle. These are these coordinates. How do we figure out that one? Very easy. So if we look here, basically we can define a triangle. Yeah, let's go till here, and this guy can go up to here. Let's say like that, right? So obviously x and y basically there. So this x, it's xc plus this particular length. So let's say it, this is d1 plus d1, and then y is yc, and since we are going upwards is minus d2, right? So these are the right formulas, but we need to figure out d1 and d2, and that one is very easy to figure out, because d1, so this one, if we know the angle, right? So we know that cosinus of angle A is d1, right, over this hypotenuse, right, which is r. And then for d2 we know that sinus of angle A is d2 over r, which is d2 over r, right? Therefore if we write it again here, x equal xc plus d1 is r cos A, r times cosinus of angle A, and y is yc, so x and y for the center of the circle, minus here, not plus, r sinus of angle A. All right, so we know the angle, we know the radius, we know the center of the circle, so we figure out basically the formulas to calculate them, these x and y values. All right, so we're gonna use this formula set in our code. So let me switch back to the code here. We're gonna return back to the notebook if we forget those formulas, and let's use here. Let's look through all the. Let's have some constants here. Const radius is 100. We know the 100, and the angle we're gonna loop through it. Initially, angle is 0. And we're gonna do as long as angle is less than 360 or less or equal than 360, we should do some drawing here, and then we increase the angle. Perhaps we said by a step of 5. We should not increase by 1, but increase of step by 5. And what we are doing here, we are drawing a small circle. So to draw a small circle is very easy. We can draw a small circle at x and y coordinates and a small radius, perhaps 5, right? Like kind of a dot. The question is, what is the x and y? And the x and y, let's have also the constant here. X circle, xc, those center of the circle is 400 and yc is 300. And basically x will be xc plus r times cosinus of angle, and y, it's y circle yc plus minus r times sinus of angle, just like that. And if we are running it, we should see the smaller circles arranged in a circle kind of formation. We can increase the angles by 10 here to space them out. It's working fine. We can make the radius bigger. And of course, this example is with just small circles, but perhaps we're gonna implement in the future one of those analog clocks, right? When the hand is moving like in a circle, and also instead of the small circles, we can place numbers, right? The numbers that go around the clock, so we can place them like that. So it's basically a pretty useful algorithm to kind of go around and place those. As a matter of fact, we can display here next to each of them, we can put a text, for instance, angle, we can display it an x and y coordinate. And we can see the numbers here, right? If we don't display the circle, we should see the numbers much better, 0, 10, 20, 30, and so on. See, 180, and goes up to here, right? Perhaps this is nicer just to display the numbers. So let's encapsulate this in a function, just to have it like a functions numbers on circle, and this basically we pass the coordinates of the center of the circle and its radius as arguments, right? Similar to how you the same kind of arguments that a simple circle will take. And here we move all this code inside. We don't need this as a constant, not even the radius. And now when we're gonna invoke it like this, 300 in the middle of the screen and radius 200. And yeah, we get the same effect. And just to see that basically these are on that circle of that those coordinates, we can have a circle here of these coordinates, right? Yeah, and see the text is just following this circle basically here, but we don't need this one. Numbers on a circle, or we can go back and have the circle here with a radius of 5 like we had before. Of course, this one is circles on a circle. Circles on circle. It's I'm trying to figure out a practical use for this one. Anyway, I'm gonna save it on circle. The exercise was anyway about a while loop structure and used with some graphical functions. I'm gonna save it and share it with you. Circles. All right. So this concludes the today lesson about while loop structures. As you can see, now we have more powerful and more ways to do repetitions. We learned before about the for loops, the for off structure. Now we saw while loop and do while loop, the other one where the block was basically executed before the condition. Of course, when we are doing animation, we also know about that concept where the browser invokes the loop function up to 60 times per second, but that's a different concept used for different things. And yeah, with this new instruction in your toolbox, we can implement more complex algorithms such as the bubble sort that we did today. And again, I hope that you have fun. Thank you for watching. Happy coding, and see you next time.